Hello students, good morning. I hope you all are safe and healthy at your home. Welcome in this lecture. Today we will discuss about heterocyclic compound which having 6 member ring and fuse system. So, member ring heterocyclic one or more heteroatom and fuse heterocyclic compound. According to our syllabus, we have only two remaining compound. So, we will start with our today's compound is quinoline. 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 It is also known as alpha beta benzopyridine. So it is fused 6 member ring fused heterocyclic compound. It is also known as 1-azanaphthalene. We well know about structure of naphthalene. Double benzene ring containing one heteroatom, nitrogen as one heteroatom. It is known as quinoline or alpha beta benzopyridine or 1-azanaphthalene. Quinoline was first isolated from coltan. A scientist named Runge, 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 in 1835. First of all, quinoline is first isolated from coltan by Runge in 1835, but later on in 1842 it was obtained by the heating alkaloid cinchonine or quinine, cinchona tree. Natural component cinchona tree contains cinchona. Cinchona or cinchonine or quinine. It is chemically known as quinine, which is natural anti-malarial drugs. So, cinchona with alkali. It was obtained by heating cinchona with alkali. Structurally, we see the molecules is made by the fusion of benzene and pyridine ring. Fusion by benzene and pyridine. So, so it is coming from fuse 6 member ring, one hetero nitrogen as heterocyclic compound, and thus it has the same relation to pyridine as naphthalene has to benzene or indole to pyrrole. The system of numbering in quinoline I describe here. Nitrogen heteroatom is number 1, so 1, 2, 3, 4, 5, 6, 7, 8. These are the system of numbering in Quinoline. So this is short introduction. Now we see preparation. Quinoline occur in coal tar and burn oil. Coal tar and burn oil, from which it may be extracted with acid or it's made by synthetic methods. Naturally from coal tar and burn oil, but it is also made by synthetic methods. We have some methods. So we start quinoline with synthetic method. First method was given by Scrum. 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 So it is known as Scrum's synthesis method. SKRAUP''S. Scrum's synthesis. Scrum's synthesis. In 1880, Scrum given this synthesis. This is the most important method for the synthesis of quinoline, and for this synthesis consists of heating a mixture of aniline, glycerol, concentrated sulfuric acid and ferrous sulfate in presence of an oxidizing agent. Generally, nitrobenzene is used as the oxidizing agent in scrub synthesis because aniline, a reactant, is produced by its reduction. Such as nitrobenzene, stannic chloride, ferric salt or arsenic acids. So we see the synthesis of quinoline, which is known as Scrum synthesis. First of all, we treated glycerol, dehydration of glycerol by hot sulfuric acid to form unsaturated aldehyde, which is known as acrolein. So first of all we start with glycerol. CH2OH, CHOH, CH2OH. It is glycerol, and it is treated with concentrated sulfuric acid H2SO4. So it is converted into aldehyde. 2 moles of water molecule produced, and it is acrolein. ACROLEIN, acrolein. So dehydration of glycerol by hot sulfuric acid to form unsaturated aldehyde. This unsaturated aldehyde is treated with aniline, and we obtain beta phenyl amino propionaldehyde. This acrolein is treated with aniline. We have structure aniline. Benzene ring contains NH2. Benzene ring contains NH2. So we get a cyclic compound. Condensation takes place. So NH condense with CH2, CH2, CH double bond O, CH2, NH is condensed with acrolein. So CH2CH2CHO, this is CHO, and it is beta phenylamine, phenylamino, not amine, propionaldehyde. Propionaldehyde. Here, nucleophilic addition of aniline with the help of acrolein, it converts into beta phenylamino propionaldehyde. Electrophilic attack on aromatic ring by the electron deficient carbonyl carbon of the protonated aldehyde. So cyclization takes place and we get 1,2-dihydroquinoline. 1,2-dihydroquinoline. So dehydration of secondary alcohol to form 1,2-dihydroquinoline. 1,2-dihydroquinoline. Cyclization takes place. This is 1,2-dihydroquinoline. 1,2-dihydroquinoline. And oxidation of 1,2-dihydroquinoline by nitrobenzene. With the help of nitrobenzene, we stated first, nitrobenzene is used as oxidizing agent. So, oxidation of 1,2-dihydroquinoline by nitrobenzene resulting in aromatization to form quinoline. Aromatization to form quinoline. We have structure nitrobenzene. And with the help of FeSO4, so we get quinoline, and mixture of NH2 aniline, recovery of aniline. At the end of synthesis, we get mixture of quinoline and aniline. The Scrum reaction is of wide application. The reaction can be also used preparing benzopyrrolium salt. Benzopyrrolium salt. In previous lecture, we studied about benzopyrrolium salt. It is known as coumarins. So, preparing benzopyrrolium salt for which phenols are used in place of aniline. So, Scrum reaction is of wide applications. A large number of substituted quinoline have been prepared by using substituted anilines. And this substituted aldehyde or substituted ketone is also used. So this is very important synthesis known as Krebs synthesis. Now we see more synthetic route for the quinoline. Here we stated some substituted derivatives of aniline is used. Substituted quinoline have been prepared by using substituted anilines, aldehydes and ketones. So we see orthoaminophenol. We get quinoline from orthoaminophenol. This is orthoaminophenol, which is treated with glycerol. We write down structure in above synthesis. With the help of sulfuric acid and nitrobenzene. So we get derivative of quinoline, and this is 8-hydroxy quinoline. 8-hydroxy quinoline. It is also known as oxide. 8-hydroxy quinoline. It is very important compound as a reagent. 8-hydroxy quinoline. So, with the help of aniline substituted compound 8-aminophenol is treated with glycerol, sulfuric acid and nitrobenzene, we get 8-hydroxy quinoline. Here we have some more synthesis. So meta-substituted aniline have been two ortho position free, and hence two different quinolines are formed. The 5 and 7 substituted quinolines. Meta compound, meta substituted aniline have, this is ortho, so it has only one product. But if we use meta substituted aniline, so this have two ortho positions free, and hence we get different form of anilines, that is 5 and 7 substituted anilines, quinolines. So we see number 3, metachloroaniline. Metachloroaniline. And this is treated with same reagent, glycerol, sulfuric acid, C6H5NO2, etc. We get mixture of 5 and 7 substituted quinoline. This is nitrogen. This is quinoline. So we start with 1, 2, 3, 4 and 5. 1, 2, 3, 4, 5, 6, 7. So these are 7 chloroquinoline. And this is 5 chloroquinoline. So with substituted meta aniline have two ortho positions free. So we get 5 and 7 substituted anilines. In such cases, the 7 substituted product predominate when meta substituted is activing group, but on other hand 5 substituted product predominate when meta substituent is the deactivating group, such as nitro group. we see one more example. For general mechanism of synthesis which does not involve the condensation of imino group with carbonyl group. Imino group with carbonyl group. And had this group been condensed to give skiff base and then cyclized to give quinoline. If we treated parachloroaniline, ortho, meta and this para position. This is parachloroaniline. Same reagent, glycerol, sulfuric acid, nitrobenzene, etc. It converts into 6-chloro. 1, 2, 3, 4, 5, 6. 6-chloro. Quinoline. 6-chloro-quinoline. Now we see more two examples confirm the general mechanism of synthesis which does not involve the condensation of imino group with the carbonyl group. So I rub out this ortho, meta and para substituted aniline and we see more example. Aniline number 4. Aniline is treated with crotonaldehyde. CH3 CH double bond O, that is CHO. It is crotonaldehyde. This is aniline. So we get same reagent, we get 2 substituted quinoline. 2-methyl quinoline. 2-methyl quinoline. It is also known as quinaldine. This is aldehyde, and when we treated this aniline to ketonic group, the compound CH3CO CH double bond CH2, it is known as vinyl methyl ketone. Aniline. With the help of glycerol, sulfuric acid, nitrobenzene, etc., we get 4 substituted compound, and that is 1, 2, 3, 4. 4-methyl quinoline. 4-methyl quinoline. So these are the two more examples come from the general mechanism of synthesis, which does not involve the condensation of imino group with the carbonyl group. Carbonyl. So aldehyde and ketone both contains carbonyl, C double bond O group. And had this group been condensed to give skiff base and then cyclized to give quinolines, the position of methyl group would have been reserved. For aldehyde it is 2 substituted compound and ketone it is 4 substituted compounds. We have one more useful or important synthesis for quinoline, so we will see it. Number 6, Friedlander's synthesis. Friedlander's synthesis. In 1879, Friedlander's condensing orthoaminobenzaldehyde with some aldehyde and ketone containing reactive methylene group. So we get quinoline derivatives. In 1879, Friedlanders give this method. So it is known as Friedlander's synthesis. Orthoaminobenzaldehyde. Orthoaminobenzaldehyde. This is CHO and NH2. So it is orthoaminobenzaldehyde treated with aldehyde or ketonic material. Aldehyde or ketonic material. The method consists of condensing the orthoaminobenzaldehyde with aldehyde or ketone. It is aldehyde. This R is substituted by hydrogen, then aldehyde, and this is alkyl group R. These R and these both are these R dash, I write R dash. So R and R dash are alkyl group, then it is ketone. So aldehyde or ketone containing a reactive methylene group adjusts to the carbonyl group in aqueous sodium hydroxide. In aqueous sodium hydroxide NaOH and removal of 2 water molecules, we get 2,3 substituted quinoline derivative. Quinoline derivative. So this is very important method for synthesis of quinoline. We have also Dobrener. We have also synthesis Dobler-von Miller synthesis, which gives quinoline. One more, Friedzinger synthesis. which is also a important synthesis for the synthesis of quinoline. One more, number 9. Conard Limpach and Nor synthesis. Conard Limpach and Nor synthesis. And some other synthesis. Also we have large number of quinolines have also been prepared by the cyclization of the appropriate aniline, generally obtained by the reduction of corresponding nitro compounds. So we have more some synthesis, but we stop here synthesis of quinoline. Now we see the properties of quinoline. Quinoline, it is colorless liquid in form of liquid, so its boiling point is 237 degrees Celsius. It possesses a characteristic odor resembling to pyridine. Its basicity is of some order as that of aniline. It is sparingly soluble in water but completely miscible with most of the organic solvents, as for example ethanol and ether. These are most important solvent, ethanol and ether. Due to its high boiling point, it is a useful high boiling solvent for various types of organic compounds. Moreover, the basic character of compound made it useful during the various chemical reactions where the two reactants are combined by the removal of a hydrogen atom from one of reactant and a halogen atom from the other. So these are the very important basic properties of quinoline. The most of tertiary amine, it forms salt with inorganic acids. So we see the chemical properties. We discuss about chemical properties of quinoline. I write down quinoline in center. Quinoline. The most of tertiary amine, it forms salt with inorganic acids. And quaternary or salt with alkyl halides. As for example, if we treated quinoline with hydrochloric acid HCl, then quinoline hydrochloride obtained. And HCl, this is minus and N is plus. It is quinoline hydrochloride. If we treated with methyl iodide CH3I, then we get its acid. here CH3I joined. So it is quinoline methiodide, quinoline methiodide, or N-methyl quinolium iodide, N-methyl quinolium iodide. So it is most of tertiary amines. It forms salt with inorganic acids and quaternary or salt with alkyl halides. Now we see electrophilic substitution reactions. Electrophilic substitution reactions of quinoline, sulfonation and nitration with the help of sulfating agent, concentrated sulfuric acid at 220 degrees Celsius. So it is formed in 8 substituted 1, 2, 3, 4, 5, 6, 7, 8 SO3H. This is 8 substituted 8 sulfoquinoline, 8 sulfoquinoline, and if we heat it more than 300 degrees Celsius, more than 300 degrees Celsius, then this 8 compound is transferred to 6 substituted derivatives. So it is 8 sulfoquinoline, and this is 6 sulfoquinoline. So we get on sulfonation, electrophilic substitution on 8 and 6 position with the help of nitrating mixture, concentrated HNO3. So we get we get 5 nitro and 8 nitro, 5 nitro and 8 nitro quinoline. With the help of nitrating mixture, it is converted into 5 nitro and 8 nitro. And if we treated low strongly acid, it is concentrated nitric acid, but we dilute HNO3, then we get 3 nitro. 1, 2 and 3. This is 3 nitro quinoline. 3 nitro quinoline. So these are the electrophilic substitution with the help of nitration and sulfonation. With the help of sodium amine NaNH2 with the help of aminating and alkylating nucleophilic substitution we see now. With the help of NaNO2 we get 2 and 4 substituted 1 and 2. This is 2 amino and and this is 1, 2, 3 and 4. Here NH2, sorry. This is 4. This is 2 amino and 4 amino. Quinoline. So, amination takes place at 2 and 4th position. Now we see alkylation with the help of lithium. Alkylation, RLI, CH3Li. So, and also we get aromatic alkyl quinoline with the help of lithium. So we get this R, or aromatic compound is present, then it is 2-alkyl or 2-aryl. Quinoline. 2-alkyl or 2-aryl quinoline. When we treated this compound with halogenation, quinoline undergone by halogenation at low and high temperature with the help of Br2 at 500 degrees Celsius, then 2-bromoquinoline. 2-bromoquinoline. I write down only name, not structure, but you all are write the structure with complete electrophilic substitution. So when we treated bromine at 500 degrees Celsius, then we get 2-bromoquinoline, but only bromine in vapor phase, Br2 vapor phase. So it is converted into 3-bromoquinoline. 3-bromoquinoline. We have two more chemical reactions for quinoline, substituted reactions, oxidation and reduction. So I rub out these structures and we see last topic, oxidation and reduction. Quinoline with the help of KMnO4 oxidation takes place. So first of all, oxidation takes place and ring opening. One benzene ring is converted into carboxylic group. So it is known as quinolinic acid. Quinolinic acid. Quinolinic acid. And IUPAC, it is pyridine 2,3. 1,2,3 dicarboxylic acid. Dicarboxylic acid, and decarboxylation takes place minus 2 CO2 or CO2. It convert into COOH. It is nicotinic acid. NiCO. Nicotinic acid, and also it is known as pyridine 3 carboxylic acid. It is very important reaction. Oxidation. It depends on electron availability. Carbon permanganate oxidation will be destroyed the benzene ring and leave the pi deficient pyridine ring intact. Thus, various oxidation of quinoline oxidize benzene ring to form quinolinic acid. Quinolinic acid. And last we see reduction, catalytic reduction attack. Catalytic reduction attack. Preferentially, the more electron deficient pyridine ring of quinoline. We see with the help of lithium aluminium hydride LiAlH4 or sodium amine NaNH3, both reagent we discuss in our reagent topic. So it is converted into 1,2-dihydroquinoline. 1,2-dihydroquinoline. The double bond from here is removed, and this is 1,2-dihydroquinoline. So it is very important reduction process. If we take this compound as acid metal reduction with the help of Sn plus HCl, H2Ni. So we get 1, 2, 3, 4 tetrahydroquinoline. 1, 2, 3, 4. Both double bond of pyridine benzene ring removed. So it is 1, 2, 3, 4 tetrahydro. Tetrahydroquinoline. And if we react with H2PT, platinum reduction, then we get loss of double bond in both benzene ring. It is decahydroquinoline. Decahydroquinoline. These are very important reduction of quinoline to decahydroquinoline. Here we stop our this lecture, and we have only one compound, phenoxazine or benzoxazine. So we will see it in next lecture. Okay, thank you.